In the next few minutes, I'd like to add a few more details on the histogram and box plots and exactly how that works in GeoDA program. When you work on histogram, the assumption is that you have a frequency table describing the data items as the entities and frequencies. For example, the tornado data on states, we have this frequency table by state and by the number of tornadoes for each state. If we have that kind of data, we can visualize this frequency table by a histogram. So a histogram is basically a bar chart that the height of the bar represents the proportion of the instances in that range, in that bar range. And the number of bars can be customized. You can choose how many intervals for the histogram. In the GeoDA program, there's option that you can choose how many intervals. So the shape of this histogram will reveal the kind of distribution, whether it's a kind of a normal distribution or the kind of screwed distribution. For example, the histogram at the bottom shows that there's about 30 states that have tornado numbers below 20. Okay? And there's about 10 states that have tornadoes number between 20 to 39, etc. So there's no states have tornadoes between 90 to 100 basically, and there's one probably or one state which I know this is Texas is have the highest tornado of 147. So all this bar chart showing visually showing the distribution occurrence, and we always draw the data value range on the x-axis, and we always draw the frequencies on the y-axis. The shape of the histogram tells us a lot about the relative distribution of values across this range. For example, the histogram A basically shows screwed on the left side. In this case, we can expect that the majority of the values are low values. The histogram B shows another screwed distribution. We call it negatively screwed distribution. In this case, you can expect most of the occurrence observation have higher values. Extreme value is on the lower ends. Then the histogram C represents there's a central tendency in the middle, okay, and other values are distributed around this middle value. And this is kind of what we call normal distribution. It's kind of ideal case, but some of the shapes are close to that ideal case. When the distribution is close to normal distribution, box plots can also be applied to describe the statistical patterns of central tendency and the dispersion of values. Okay, so for example, if we calculate the interquartile range, basically it will capture about 50% of the value that is around the median, the mean value. Okay, so Q1 and Q3 define the range of the IQR. And then anything that beyond this what's called hinge value, which is there's a top hinge value is really Q3 plus 1.5 times of IQR, and any value beyond that we consider as an outlier. And the same way on the other end of the hinge, we can extend, we can find a point where the value is a kind of Q1 minus 1.5 times of IQR, and any values between or below that value will be considered as a low end of the outlier. So this is the way that Boxplot works, and you can pretty much use a similar fashion with the z-score on the use a standard deviation as a way to measure the outlier. Making a box plot in GeoDA or OpenGeoDA is relatively easy. However, you do need to have knowledge or skills to interpret the box plot in the correct fashion. So here I give you 4 examples of different kind of distribution as box plot, and I hope that you can interpret those charts or graphs in the right way. So, for example, what the red block mean? Okay, what does the green dot mean? What is the orange line mean? What is the thin gray line on the top and the bottom mean? Okay, so where can you find the extremes and outliers, and where can you find 25% on the top, 25%, or lower to 25%, or the 50% line? Okay, so and we can also ask which box plot showing a skewed distribution, and the box plot also shows how dispersed. Okay, the narrower the box, the less dispersed the values are. You can also make a scatter plot display in OpenGeoDA. The difficult part again is how do you interpret the scatter plot for making sense of your data. What I showed here is 2 kind of scatter plot. That on the plot on the left side shows there's a positive correlation between the 2 variables, and the plot on the right side shows there's a negative correlation between these 2 variables. Okay? So in terms of the slope of this line, we call regression line, does that represent the strength of the correlation? Well, it may or may not be, because the different scales of each axis could make this particular slope very different, even they reflect the same data. So in OpenGeoDA, we have an option to create the scatter plot so that both axes are normalized. Okay? When they are normalized, then we can interpret the slope of this regression line as equivalent to the correlation efficient. So in that case, we can compare the correlation between 2 variables. So now I would like you to try to interpret these 2 scatter plots and see what you observe by interpreting the scatter plots. Okay, remember, the 2 axes represent 2 variables. Okay? The general pattern is there's a few possibilities, is that as one variable change, the other variable also change in the positive way. Now, if one variable grow, the other variable also grow. We call it a positive correlation. Okay? You have also another case that as the primary variable kind of increase, the dependent variable kind of decrease, then we call it negative correlation. Okay? And third possibility is that one variable change, the other variable doesn't have any change. Then we have basically no correlation between these 2 variables.